Here we have a simple series circuit. In this video, we're going to find its equivalent resistance, we're going to find the current, and we're going to visualize the voltage and the current along the circuit. So let's get started. Now first, let's find the total resistance, or the equivalent resistance. Now because this is a series circuit, we have 3 resistors in series here. So in order to find resistance, all we have to do is add up the 3 resistors. So we have 3 ohms plus 9 plus 6, which gives us 18 ohms. The current can be found using Ohm's law, which states current is equal to voltage over resistance. Our voltage is 12 volts, and we found our resistance, that's 18 ohms. That means our current is 12 over 18, which gives us about 0.667 amps. Let's talk about voltage drop. So in a circuit, the voltage rises in the battery and then it drops as it passes each resistor. The voltage drop in a circuit can be found using Ohm's law. So let's go ahead and find the voltage drop across this first resistor. We'll call it R1, and the voltage drop, we'll call that V1. So V1 is going to equal current times resistance, R1. Now we know our current. We have our value for R1. So V1 must equal 0.667 amps times 3 ohms. And that gives us a voltage drop of 2 volts. Same for this resistor. We'll call this R2. And we'll call the voltage drop across R2 V2. V2 is going to equal the current times R2, which is 0.667 amps times 9 ohms. That gives us a voltage drop of 6 volts. And for our last resistor, we have our current times the resistor, 6 ohms, and that's going to give us a voltage drop of 4 volts. Now we used the same current for each of the 3 resistors. That's because in a series circuit, the current is going to be the same all throughout. Here's a graph of the voltage for this circuit. So we start at 0 volts here at point A on the negative terminal of the battery. The voltage goes up to 12 volts once it's across the battery. Then it drops by 2 volts across the first resistor. It drops by 6 volts across the second resistor. And then it drops by 4 volts across the last resistor, bringing us back to 0 volts so that the cycle can start over again. Here's sort of a 3D representation of what's going on in the circuit. You see we start here at point A. We jump up 12 volts across the battery. And then as we move along and we go across resistors, the voltage drops off, back down to 0. I hope this is a clear representation of what's going on. This took a while to make. Here's a graph representing the current through the series circuit, where the current stays the same at about 0.667 amps all throughout the circuit. And here's a visualization of the current along the circuit. As you can see, it stays the same all across. Or maybe you can't. This one's a little bit more messy. But I hope you enjoyed this quick rundown on series circuits. I hope you found the visualization on the graph and the 3D graph helpful. Thanks for watching.